Hello, algebra. Welcome to the video on the distance formula. So I'm going to do a couple things to help the distance formula make sense. Then I'm going to show it to you and do an example. So the distance formula is just something there to tell you the distance between 2 points. So here I've given us 2 points. I have this point right here, 1, 1. And that comes from going over on the x-axis a distance of +1, and then on the y-axis a distance of +1. And that's how I know that that's the point 1, 1. And then over here I have the point -2, 1. And that comes from going a -2 in the x direction and then a +1 in the y direction. And that's how I know that's the point -2, 1. So let's say I want to know the distance in between these 2 points. One thing I can do is I can just count. These points are on the same line, so I can just say, look, I have 1, 2, 3. The distance between these 2 points is equal to 3. So I could do that with a horizontal line. Horizontal lines are lines that go from the left to the right, like this. Horizontal. I can also do this with vertical lines. Here I have the points 0, 1 and 0, 2. And again, I can just count here and say, look, there's 1, 2, 3. The distance between these 2 points is 3. You can do that when you have a vertical line. But what if we have a more complicated example? What about here? I have the point -8, 6 and the point -2, -1. I can't just count this because these 2 are on a line that's not vertical and it's not horizontal. Ooh, let's just use the ruler, shall we? If I connect these 2 points with my handy dandy ruler, much better. This line is not vertical, it's not horizontal. Because it has a slant. All right, so how do I find the distance between these 2? Well, some of you might remember from your geometry classes that we have actually a formula that can help us here called the Pythagorean theorem. Pythagorean theorem was not invented by Pythagoras, but he did make it famous in the Greek world, and then in the Western world, we're very obsessed with the Greeks, so that's why we call it the Pythagorean theorem. But you can actually find evidence of the Pythagorean theorem in Ethiopia, which is where historians think Pythagoras found it out. He went traveling to Ethiopia and then came back and was like, look at this theorem, guys. But anyway, the Pythagorean theorem says, if I have a right triangle, this little square here means it's right. Now, a right triangle is when this in here is 90 degrees, this angle. And the distances of my triangle, the lengths of each of those sides are a, b, and c. And the Pythagorean theorem says that a squared plus b squared equals c squared. How can this help us? Well, what I can do here is actually draw myself a triangle. And now I've got a right triangle here. And now I can actually do some counting like we did before. So I can count this way, 1, 2, 3, 4, 5, 6. So this distance is 6. And I can count this way, 1, 2, 3, 4, 5, 6, 7. This distance is 7. And what I want to know is this distance. So the Pythagorean theorem says that the distance we're looking for, if I square it, let me make that a little neater for you guys. distance squared should be equal to 6 squared plus 7 squared, which is 36 plus 49, which is 85. So if d squared is equal to 85, and we want to know what d is, we can just take the square root of each side. And then now we know the distance is equal to the square root of 85. I wonder if we can simplify this square root. Let's figure it out. So I see that it's divisible by 5 because it ends in 5. So let's see, that should be 5 times 17, is that true? 17 times 5? 35, carry the 3, 5, 70. Yeah, so it's 17 times 5. And 5 and 17 are both prime. And I don't have any perfect squares, so I actually cannot simplify this distance any further. So this can be our final answer for the distance. The distance between those 2 points is the square root of 85. Now I'm going to show you how to do this same problem, but instead we're going to use a formula. So here we have the distance formula. You can find this in your textbook. Distance formula says the distance between 2 points is equal to the square root x little 2 minus x little 1 squared plus y little 2 minus y little 1 squared. And so let's try this out using our 2 points that we just did. So if we know if we get the answer square root of 85, we know we're doing it right. We know that this formula works. So let's say we're going to use these 2 points, -2, -1, and -8, comma 6. Let's see what we can do here. So here's how I plug these into the formula. These x's, x2, ooh, sorry, I wanted the highlighter. These x's, x2 and x1, are talking about these x values here. And this y2 and y1, they're talking about these y values here. So all I have to do is keep track of what's what, and I'll be okay. So let's suppose this is x1, y1, this little point here, and this point is x2, y2. So I'm going to put in -2 for x1, -1 for y1, -8 for x2, +6 for y2, and then I'm going to do that computation. So d is equal to the square root of -8 minus -2, quantity squared, plus 6 minus -1, quantity squared. So let's go ahead and do some simplifying in here and see what we get. If I take the square root, in here I have a negative and I'm subtracting a negative, so that becomes addition. So I have -8 plus 2 squared. And then notice we've got the same exact thing is happening here. So we have 6 plus 1 squared. And that gives us the square root of -6 quantity squared plus the square root, or plus 7 squared. And now a common mistake here is this negative sign. notice that the negative is inside parentheses. So that means if I take -6 and I square it, I'm taking a negative times a negative, which makes my result a positive 36 plus 49, which gives me the square root of 85. And that's our distance. And that was the distance that we got by using the Pythagorean theorem. So here is our distance formula we can use every time. D is equal to the square root of, oops, sorry guys, x squared minus x1 squared plus y squared minus y1 squared. That's our distance formula.